If not yet, yeah, you can have a look. I've already uploaded, right? So I'm gonna take some time inside our practical this morning to talk about the coursework. Okay, coursework assignment. Right. So let me share my screen so you can see what I'm talking about. Yeah. Okay. So if you open your classroom, okay, you can see the coursework, and the coursework you have assignment, and when you click view assignment, okay, sorry, not that. Here, you click that, right? It will open up to this folder, okay, and you get all the document here, yeah. So I'll talk briefly about some of the documents, but mainly I will talk about the assignment question, right? Okay, so just go to here. All right. So okay, this assignment. First of all, I want to talk about whether it's a group or individual assignment. It can be both. Okay, you pick either, right? If you want to work in a group, unfortunately, yeah, there's a maximum 2 members in a group, right? Or if you want to do it solo, it's also allowed, yeah, right? So because there are 3 of you, so that means at least one. If a couple of you wants to do as a group, that means at least one group, one solo, okay? Or each of you want to do solo, also okay, right? But the maximum members in a group is only 2 persons, all right? So if any of you do decide to want to do in a group, and every member in the team must contribute and participate, right? So that means you have to make effort, right, to show your part of the work. What did you do? Yeah, right. If you're in the team, right? Okay, so the weighting towards the assignment, right? So this is the only assignment, so that means it's 100% marks you get from this assignment. Means 100% of that mark goes to assignment. Okay, but assignment is just one part of your coursework. All right. So your coursework also includes the midterm test and the skill-based assessment. That means skill-based assessment, but here practical tests. Okay, so you have other 2 components, right? So if I'm not mistaken, the midterm test is 30%. The skill-based assessment, which is practical test, is 40%. So and this assignment is 30%, right? But since this the only assignment we have, okay, that means the total here 100% means what marks you get from this assignment will be 100% for the assignment component of your coursework. Okay, right? Any question? Just raise up, unmute and raise up straight away. Now submission deadline is week 11, Monday, 29th of March, latest by 6 p.m. on that day. So if you want to just have an inkling, when is that? Now we are 5th of February. Okay, so not exactly 1 month in February, but you are basically 3 weeks in February, and another 4 weeks, right? 4 weeks, I mean 7 weeks for the assignment to do, because this is the deadline specified 29 March. Okay, that is by 6 p.m. right? So you will have I think we'll have enough time to complete it now. Later we'll look at what's content of the assignment. All right. Okay, so all your documents that is required for you to submit, you will upload into the Google Classroom, right? Via the classroom earlier on. I show you here, right? Okay, and we go back here. So there are two parts to assignment. The first part, part A, is worth 20 marks and of assignment component, and part B is worth 80 marks of the assignment component of your coursework, right? So let's have a look at part A, right? So you will be given two packet tracer questions, right? So even if you are a group, you still need to do it on your own. That means if you're in a group, let's say you have two members, then doesn't mean that because you're a group, then you only you both a member can submit just one copy of the two packet tracer questions. Okay, that means even if you're a member of a group, each member must also do the packet tracer question. Okay, so that means everyone must submit that, right? So there are two. The first packet tracer question for part A is submitting scenario. Second one, to design and implement a VLSM addressing scheme. So you can use your course plan as a guide, right? To see, because this assignment, as well as the SBA, okay, will be basing a lot of the work based on the packet tracer, okay, software. So you can see the topics that we're going to cover week by week, right? Week by week, and you can see here we start to learn about subnetting in week 7. You can see subnetting IP network, subnetting, right? Subnetting, right? By this week 7, you should be very comfortable because of all the practical exercises we have been doing until week 7, right? So you should be very comfortable in using packet tracer. Okay, you explored, you have debugged, you have you know how to basically you know how to use packet tracer quite well. So by week 7, okay, we'll learn how to do subnetting. Okay, subnetting is a theory idea, yeah. Okay, but we will have a lot of exercises for you, whether in tutorial or in a workbook format, for you to do some exercises on subnetting, right? So basically, you will learn about subnetting concept in starting from week 7, because week 6 you'll learn about IP addressing, the format, and the format is very important for IP addressing, for subnetting. So then the week after that, you learn about subnetting. Subnetting is basically you have a LAN and you want to subnet into multiple sublets, so subnets, okay, subnetworks, right? Okay, so and continuation of that to week 8, and then in week 9, okay, you will learn about another type of subnetting, which is variable length subnetting. Now, the difference between subnetting is just that subnetting, you divide the network into equal size subnetworks. Whereas VLSM means you want to divide the network into variable size subnets. Okay, so those are only the difference between these two. If you want to have equal size subnetworks, then you use subnetting. If you want to have different sizes subnetworks, let's say you're given one single network, one LAN. Okay, so you want to divide it. So you look at your requirement. If the requirement is all the subnet must be equal size, then you will look at subnets. Okay, subnetting, sorry. If you want that the subnets will be variable size, then you go for VLSM. What do we mean by variable size? It means that the number of hosts available, the host address available in the subnet, either fixed, that means all equally, okay, right? All equal number of hosts available for each subnet. That's subnetting. For VLSM, the different subnets may have different number of hosts required. So that's variable. Okay. So that's the basically the concept, the technique is the same. Slightly different is the way you approach it. Okay. So for subnet, the focus is how many subnets, because all subnets will be equal. All subnets will have equal number of hosts. So you care more about how many subnets required for subnetting. Huh? For VLSM, the focus is for each of the subnet, how many hosts is needed. Okay, you focus on the number of hosts within each subnet, because then you want to create subnets exactly equal or close to the number of hosts required for each subnet. Okay, so and then if you have a look, you have a couple of weeks before your submission deadline, which is week 11, right? Okay, and then the next week after that will be your SBA, your skill-based assessment revision. And in week 13, right? Oh, is it week 13? Yeah, should be after the revision, the next week will be the SBA test. So week 13 will be SBA test. And we are going to conduct it separate time from our lecture, tutorial, practical. We will find a time, and because it will be a simultaneous test among the branches and the main campus. All right. So, but we'll inform you when it's closer to the time, right? When is the exact time? Of course, we will try to get for everyone, all the branches and main campus students to have to basically book a time and date, okay, that all can be free, right? So let me go back to some question. Right, so these are the we can read the instruction, but the two things, the two packet tracer subnetting. First is subnetting scenario. Second is VSM addressing scheme. So if we look at it, okay, this is I open it up for you already. This is the part A, one of the packet tracer that you have to do. You can see that the addressing table is given, but there's no info. It's blank, right? So you have to provide it. Okay. So using the concept of subnetting and what you have practiced, you will then you use this packet tracer to implement. So that means this table, that means you have to create a Word document to store it in, to recreate this table. It's quite easy actually. If you, I'm not sure whether you guys have realized in doing the, let's say I have a Word like that. You can basically do this. You can, if you copy this into Word, it will become the table, right? So you can just basically, if this is a table that you have to fill in, you can just copy paste, and then you can now in Word you can fill in, right? Do you guys realize this? You can just actually copy if this table is need to be filled in, just copy the table from inside packet tracer itself. You can just paste it into your Word document. So then you can then use the Word document to key in all your answers. All right. I'm not sure whether you tried that. Okay, but now you know, right? You can do that. So you don't have to design from scratch. This table again if you want to recreate this table in Word. Right. So the part one of the first packet tracer is design an IP addressing scheme. Okay, after you design it, then you assign. Of course, when you design, right? When you design, you have to document it, right? Then you have to answer these questions. Okay, this answering this question is part of that answer for this packet tracer assignment. All right, and then after you design and answer this, then basically when you design, you have to write in based on this question. You can see once you design, you can fill up. Okay, when you create the subnets, then all the subnets numbering is here, is shown to you, and then you need to fill up for subnet 0 for the subnet address, and then so on, so on, so on. But don't worry about it right now because we have not reached that stage to actually understand. But I just show you roughly what you need to do. Okay, so you that means if you need to fill up this one, you have to copy this into your answer Word document. Okay, and then fill it up. Yeah, fill it up. Once you have all the addresses, okay, as a network administrator, you have to decide for assigning the address to your network devices and the interface on your router. So that's why this comes in. You see, from the addressing that you have created, okay, you will follow the instruction given here. Okay, assign IP addresses to network devices. All right. Okay, so you configure the LAN interface, and how do you know which address to pick from? You can see there. Assign the first usable IP address in each subnet. So each subnet here, what is the first usable IP address? Then take that IP address, right, and assign it to the router one, right, for the two links and WAN link, right, and then so on. And you just follow this, and when you follow this, you know, oh, okay, I need to use that for that, use that for that, right? And then what will happen is that you know how to fill up this, right? And next, you'll have to use that table with the address that you have already figure out, from here, and actually configure. Let me just go to the, yeah, I think this is the packet tracer for that. Configure that. That means the address, once you know the address, you configure it onto the actual devices in this packet tracer. Okay, once you complete that, you can see there, step 1, configure R1 LAN interface, configure IP addressing on S3, configure, and then final step here, verify connectivity. Okay, so verify connectivity just simply means if you go to one PC, then you try to ping all the other PCs. Okay, or all the IP address. If you want to do systematically, if I go to PC1, then I ping all the IP address I assigned. If all the ping is successful, okay. Oh, sorry, not PC1. They specifically want you to ping from router 1, switch 3, and PC4, right? Then from there, you ping all other IP address. If your configuration was correct, then all the ping should be successful. Later we'll talk more about ping, but I'm just gonna show you ping basically is doing this. Ping, let's say a ping Google, not sure Google alone or Cisco. Right? Some servers they disable their ping service because they don't want too many traffic from people pinging their server. But Cisco usually allow. So if I ping Cisco, when you see something like this, reply all this information, that means successful, right? If you don't see this and you see a lot of errors, that means not successful. That means some part of the configuration or your design of the subnet is wrong. If everything goes well, you should see all this reply, all this correct. That means when you ping, That means you can reach Cisco, Cisco can reach you. Okay, in this example, I use Cisco. Okay, this is what we call ping, right? Pings using ICMP, right, to diagnose the path your message flowing through. Okay, so this is, of course, when you start doing this, if you encounter anything that you're not sure about, right? Okay, of course you can ask me, right? You can ask me, and I try to explain. All right, so this part, this is what you need to do. Okay, all right. So moving on to the second one. Trying to see. No, go back here first. So that was subnetting scenario. So the second one is design and implement a VSM addressing scheme. So I just want to show you that the way you can find that is when you open the drive is here. Just now we're talking about subnetting scenario, part A. Now we talk about part A2, design, implement VLSM addressing. So now that is the variable length. So let's have a look. I'm sure I've opened it already. I think this is the diagram for that. So you can see, so for VLSM, the focus is how many, if I want to subnet, each subnet, what is the required host? So you can see this is right. Now this LAN require 5, this one 47, 11, 28. So different subnet has different host requirement. What do you mean by host requirement? Means each host, we all know already, needs a unique IP address to identify that host or that end device, right? So when you design addressing scheme, when you say I can provide 47 host address here, that means the maximum number of hosts you can have in this LAN here, for example, right, is 47. Because if you provide more hosts than the available address exists, there's no point, right? Because the extra hosts will not have any address. So then if they don't have any address, you cannot reach them. Okay, so this is the second, which is a VSM for part A. Just let's have a look at very quickly at the, I'm not going to go in very detail. You can read it. Okay, packet tracer design and implement a VSM addressing scheme. Right, so what I described for subnetting also applies here. You create another Word document. Then if you need to fill up the table, just copy paste the table into Word, so you don't have to recreate it from scratch, right? So in this packet tracer, you design a VLSM addressing scheme. And when you design, it doesn't involve packet tracer. Design, it involves you creating using the theory. We thought about it, right? During the one of the week. Okay, how to create a VLSM addressing scheme. So you do it with pen and paper usually. Okay. Yeah, and then configure the addressing on the network devices and hosts, which means after you design your addressing scheme, all right, so for this subnet, give this subnet this network address, this range of host address, okay, and of course it's you based on the number of host address required, right? So once you design like that, for each subnet, you said, okay, this network address for this, network address for this, the range for this, and so on. Then you will configure. That means the second thing you need to decide, and it's given in here, is right. From this range of address, which address I need to assign to this host, this router interface, and so on. You have to figure that out. Okay. Usually it's given here. The question will tell you like this: assign the first usable, blah 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 blah. Assign. So you will then look at your range of address, and then you will assign. Right. After you assign, then you configure. Then you actually go into the packet tracer file, and Okay, so I already assigned this one. So now I have to configure it. So I actually have physically, I have to go here, go to IP configuration, and of course not DHCP anymore, right? Because you assign manually. So you have to type in, right? Those address you assign. Manually configure it. Okay. So in the real world, in the industry, you also have to do this, right? You have to design, you have to document, you have to assign, and then you have to configure. But of course, the difference is here you just configure in Packet Tracer, but in the real world, you physically have to go to the switch, router, and PC to configure those address, right? Then of course, after you configure everything, verify. Verify means can message travel from now I've already configured everything. If I want to send message from this computer to that computer, you can test inside your own network. You can test between your sub network, and it should work. So again, you use ping. Okay, you ping between the hosts, right, to verify. Then troubleshoot connectivity issues as required means if there's a failure, then you will troubleshoot. Okay, so like in the real world, no matter how very careful you are, sometimes you make a typo or sometimes you just make a mistake. Then something doesn't work, cannot ping. Then you have to troubleshoot. This is also a skill you build up. Okay, the more you troubleshoot, this is like debugging your software. Remember, when you write software, no matter how good your design, when it comes to writing the software, sometimes you discover a syntax error, right? Or even even worse, you discover logic error. So what do? You debug, right? So troubleshoot basically is just debugging your network. Okay, then the more experience you are at it, that means the more you troubleshoot, the more experience you are. That means uh, you have a systematic way to troubleshoot. You have a systematic way to narrow down. Okay, to narrow down because just saying, oh, there's a problem with the network, and then of course you can do systematic from layer 1, 2, 3. You test everything, but would it be good if you based on certain condition, you actually can able to narrow down and pinpoint. I think this problem is this, and then you go straight to that, right? But this involve uh, experience, which means how do you get experience from doing the packet tracer exercises? Okay, as you make mistakes, because learning is a process of learning from your mistakes, right? Okay, so as you working with your packet tracer exercises, you make mistakes, and then of course you correct yourself, you debug, and as you actually doing that, don't worry about it. That is perfectly normal for learning. In fact, that builds experience. So next time when you encounter such problem, you already know, you already went through it, or it might narrow down later when you're doing troubleshooting or debugging your network. Okay, so troubleshoot here for me is very similar to debugging software. Okay, software when you run and then it doesn't go as when you do testing, it doesn't go it doesn't produce the expected result lah. That means there's some bug in there, so you have to do debugging. So how do you do debugging? The more you do debugging, the better you are in troubleshooting your code, right? Right. So this and so basically very similar to the previous one. The only difference is the other one was using subnetting concept. This one using VLSN concept. All right. Okay. So that's part A. So I'm guessing I haven't looked at it because we're gonna look at the rubrics. Yeah. So I'm expecting maybe if it's equal, then it's 10 marks. Right. Then we go to part B. Now, part B, you're not given any packet tracer. You know why? Because you're going to create the packet tracer. Okay? So far, all the practical exercises the network has been created for you. Someone already drag and drop all the PCs, all the switches, routers, and everything lah done, and some of the packet tracer exercise, some of the configuration already done for you. Then you just do extra things. But in the part B here, right? So still doing the either submitting or via SAM. I think you have to look at the scenario question. Again, if the question doesn't care about each subnet how many hosts, each subnet how many hosts, then that's subnetting. But if the scenario, the question is this subnet needs this how many host address, this subnet how many hundred, then you know it's VSM. So depending on the question, you will know whether it's subnetting or VSM, depending on the requirement. Right? So here you can see you are required to complete the tasks related to setting up local area network and network configuration based on the scenario. So this is the same as, let's say you go to the boss say, okay, I need this network to give you the requirement. Then you go off, design the network, either you use subnetting or VSM, depending on what the requirement is. Then you, after designing the addressing scheme, so in the real world, you go through a long process of proposing the hardware, hardware, software, and the computer. But here, no need, just because we are using packet tracer is easier, drag and drop. Okay, you decide how many computer based on the requirement. So the computer, if you want to create a LAN, you need a switch, then drag in the switch, connect all your computers together using, you select which cables appropriate, link them together, and if they need to talk to another, how many LANs you need to create, then you create. Each LAN, how many computers you create. You're basically going to, based on the requirement, create the subnets and link them together based on the requirement. So here's the scenario. Okay, so you are recently hired as a LAN engineer by Beautiful Gate. This is a new retail organization. You have been asked to design and set up a local area network for the company in different location. And immediately you know what? What do you know? There should be more than one LAN, isn't it? Right? So far that we can guess. Location A, warehouse, has 10 computers. Okay, so now you look at that. There's a requirement. So when you create the LAN for location A, warehouse, you can label it warehouse, right? The network there has 10 computers. So for that LAN, drag and drop 10 computers, isn't it? You need to create exactly as required here, right? So ground floor admin office of location B has 6 computers. There are 2 departments, HR and accounting, in the first floor of location B, and each department has 4 computers. In location C, sales and marketing, right? There are 3 rooms with 2 computers each that need to be on one subnet. So they are in one subnet. 3 rooms, 2 computers, but 1 subnet. That means only 1 LAN, right? Okay, sorry, 1 subnet. So when you see subnet, means subnet is again subnetted, then you know that it's VLSM already, variable length, right? So location D, another subnet, perhaps, right? So that means in location C you have a subnet, and since it has 3 rooms with 2 computers each, then each room is a subnet of the subnet of location C. Okay, that's how you understand that. For me, I understand it that way. Location D, another subnet. Customer service department has 3 computers, 1 network printer, and Wi-Fi access for customers. So you need to configure this for location D. So that is a requirement. Make sure you understand, you sketch up, you sketch. You can sketch, right? You can sketch first. Make sure if you are able to sketch it and list in your sketch, is basically a rough idea of how the network looks like, right? With all the no need to be. I mean, this is for your own design. Okay, this I mean, for example, if you want to, when you're programming, you want to create an algorithm, you basically write down first, right? Either you write down, you draw like flowchart, or you draw, write out a pseudocode, roughly to get an idea. Okay, how does it look like? Okay, so before you implement, okay, that sketch will help you to think about the later when you're designing, whether using subnetting or VSM, the addressing schemes, right? Okay, right, and that also, but well, some people just jump into it and start dragging in, right? Okay, but I for myself, I prefer to sketch it out first. Once I have a sketch, and then because it will help to display to myself my understanding of the scenario. Okay, so maybe better that way, right? Sketch first, sketch, don't straight away jump into packet tracer. So you are also required to design, implement, and test an addressing scheme. Okay, that's suitable for the network topology and host requirement, which is this lah, right? So after you sketch and you have an idea how many computers, how many subnets, how many subnets, and all these things, then you design an addressing scheme. So depending on this, you have to I think you will know by then, whether you're going to use the subnetting or VSM way to do the addressing scheme. Then, as the network administrator, nobody's going to tell you already, oh, use this range for that, use this range for that. You have to decide for yourself. Okay, there's normally a convention. If you have a range of address, which one you want to assign. For example, if you are both wired and wireless, which range you want to assign for DHCP for wireless, which range you manually want to use for computer. So you have to decide, right? Because in the real world, if you're designing, you are also the one assigning the address. Okay, you have to decide this one, right? So your tasks include configuring initial setting. So you already learned about what are the initial settings you need to put on the switches, right? And routers is basically very similar to switches in terms of initial settings. So what do we mean by initial settings? Remember that we need to put password, and then we need to configure this and that, the banner, the message of the day, the host name of the switch, right? Okay, do you recall that? So those are initial settings. Okay, and then after that, of course, for each interfaces that you have in there, that means now you can drag and drop already lah. You can drag and drop. You create already, right? Inside your packet tracer file, create a blank one, then you start to configure. That means you drag and drop and then configure the IP address you just have decided. Okay. Okay. Here, there's a hint here. Minimum 2 switches and 1 router should be used in the network. Okay. That means if you use one router, what does a router do? Connect all the networks together. What does switches do? Connect all the end devices together, and then to form network. So then the network, how do you connect each other? Connect to routers. So basically, all the PCs or whatever connect to switches. The end devices connect to switches, and then from the switch connect to router, and then router connect to another switch from another network, and so on. Later, as we go through the weeks, I think you probably would have realized it after the previous lecture we have, right? And then the requirement, here's the requirement to guide you, design local area based on the scenario, which I've been talking about, configure initial settings on network device, both switches and routers, yeah. And this one is, the requirement is given to you, so you don't simply use, because let's say the marker wants to go in and check, then they don't know the password. So this is fixed. Use Cisco as password for all lines, BIT204 as the secret password. Then design suitable classful subnetting IP addressing scheme for the network. Configure, after you have all the addressing scheme, configure the address on the network device and end device. Okay, you go in the PC, you go in the switch router, configure, put in all the necessary addressing. Then after, of course, after you finish configuring that, you verify connectivity between all devices. Again, we normally use ping. If you can ping from this device to this device, whether in the same network or between networks, that means you've done correctly. Okay. Then, of course, documentation is very important. So you document all your design, including the network topology design, subnet table, addressing table, Microsoft Word. Right? When you do the ping, to prove that it's work, capture the ping, means screen capture, right? Screenshot. Okay. To show that you've done the ping and it's show and the result is successful. You print screen that and include it in your document. Okay, of course, the document you got figure what, and then ping from PC what to PC what successful. Another screenshot, successful ping. You label, give a caption, yeah, properly. Okay. So if the design and implementation are correct, all hosts and devices should be reachable over the network, right? So this apply for part A also. When you're whether you are you're doing part A or part B, okay. When you open packet tracer, it will ask you for information on your user profile. So please use the correct input. Put your name, right? If you're part of the group, your name and team member, team member name. Okay. Don't leave it blank. Don't leave it as guess. Right. Okay. So after you're done, create a video. Okay. Create a video. You can use, I think, OBS is good for recording. You guys know OBS or not? Let me just go to Theranos, yeah, the open broadcast software. I think open broadcaster software. It's free, right? And it's open source. It's quite powerful. Download this, install. You can use this. Okay, I think a lot of streamers use this. Okay, and then can use this kind of. So you're not actually must use this lah. Can use other software that you like, but I think this one is very good. Okay, it's free. Importantly, it's free. You don't have to crack it or something, right? So you can use this software to actually create a video. So what's inside the video? Well, inside the video, you just explain. You open your packet tracer, open your network design, your addressing scheme. Basically, you explain what you have done. Okay, right? So explain your network design. Okay, explain your addressing design. Explain your implementation. So what did you do basically, right? Okay. Right. So if you work in a group, okay, then these are some examples of collaborative software that you may use. You may or may not use, or you may use your own favorite if it's not here. Okay, if you collaborating your team member, right? Right. If you are doing solo, okay, you may also use any digital resource from online. Okay, now if you use any digital resource from online, okay, please cite it. include it in your reference list and provide citation in your report where when you want to talk about, oh, in order to get this information about this, I use this information from, then you put your citation and then citation link to your reference list at the back of your report. Okay. In intranet, you can find the document, Harvard referencing format. This is the format that our TAUC is using for referencing. And there's also a document there about how, I mean, a little basic instruction or help how to use this. What is this Harvard referencing format and how to use it? You guys ever do any citation and referencing?
Oh yeah.
In your report? Yeah. Okay, so it's not randomly choose. Oh, I think I like IEEE. I think I like APA. Not we follow the what TAUC wants us to use, which is Harvard. Okay, Harvard referencing format. So if I type, you can type. But your first port of call is actually your intranet. You should see it there. Reference format. Okay, and if you're more like somebody who likes to automate things, you can actually use JabRef. It's free. Keeping track of your reference list, and then the best thing is it works with Word. Export to Word, so you can basically use JabRef as your citation tool inside Word. Okay, and explore this. Okay, because it actually is very helpful. So instead of manually, okay, so we have cite here, and then inside Word has its own referencing. But whether you want to use the built-in one or you want to use JabRef, it's up to you. Okay. All right. If you have any question about the referencing later on, you can ask me, no problem. All right. So any other tools you use, okay, you can actually list out, yeah. You can list out in your report what tools you use to actually complete this assignment. Right? Okay, put in one section. Right, so completing this assignment, okay, use this tool, so on. Okay, submission guideline, part A, part B, okay, including that means total 5 packet tracer files. Okay, part B, recorded video, 1 video for part B only. Part A, part B, part A, don't have any video, part B only. So 1 video only. Okay, assignment document, just as before, if you've done assignment report before, it's basically very similar. You have a front cover, table of content, declaration form, which I will show you later, assignment rubrics, show you also later, but actually follow this sequence, yeah. Then your intro page, okay, and on part A, part B, okay, you talk about because the part A got the sum you need to answer, right? And then part B, okay, and then digital resource, okay, what you use. If you use OBS to record video, include it. If you use a JabRef for citation, include it. If you ask question, even if you work solo, you use certain software, because you still can ask your teammate. If you're not your member, if you're doing solo also, you can still ask your hostmate, right? You can or me. Then what are those tools? If you go to YouTube to watch, or you go to whatever Coursera, whatever those are digital resources. Whatever you use, okay, to help you. Then you write down, okay, this part, and then the reference list at back. The last part. Remember, referencing, use Harvard referencing. So this is the background of marks. Part A 20, right? 10, 10. Okay. 10, 10. And here, quality of work 45. Then you can see what do you mean by quality of work, right? There's a breakdown there. Creativity, original work 10, design report 10, quality of recorded video 15. So you can see inside there. In fact, later we'll see the precise rubrics how you can get 15 or 10, right? Okay, we'll see that. Late submission, penalty. You can see that there's also a late submission form. If you think you're going to be late, right? And then you are late, and then you submit. You must use the late submission form, and okay, you can see the days, yeah, if you're late. 1 to 3 days, 10 marks, 4 7 days, 20 marks. That means 1 week reject coursework unless you have a very good reason, and this is case by case basis. If you have very good reason, or well, we consider good if it's something that is what right? Then come to me before you're going to be late. Okay, inform me first, then we can consider not to penalize. Okay, because there are certain things sometimes, especially nowadays during COVID, yeah, there's a lot of things that can happen. So come to me, don't come to me before to actually let me know. Then we can maybe we can ignore the late submission because that's a really good reason why, so you don't lose marks. But if there's no good reason, it's just simply that okay, you do it last minute and that's why it's late, then of course you have to do this, right? 7 days reject coursework or 0 mark. Now, if you get these 0 marks, that means you're left with 40 plus 30, 70, which means then, okay, so we don't want anybody to have to repeat the course, because if you fail coursework and if your marks is below 40, 40 to 49 can be considered for make good. Below 40, have to repeat the course. All right, and we don't want that. We don't want that because actually you shouldn't fail coursework lah, right? There are 3 component. So and they're all testing different things. So that means at least if you're not good at one component, the other two, make up for it, for example. Okay, but we aim to have all 3 components you guys are good at. That means we want to try to score, right? So for this, because I'm here to advise the assignment part, you shouldn't face low marks on the assignment, right? Okay, when you're doing assignment or you're doing report or whatever, you can always consult with me, right? Right, plagiarism and collusion. As this one is very standard. Okay, the university always, and any university always very strict about plagiarism and collusion. Okay, in the United States, some university actually impose things like proctoring software. Okay, we're not actually considering that because we know it is very invasion of privacy for student. What do you mean by proctoring software? They actually, for example, a test or exam, they actually install the software, and the webcam will basically it's like Big Brother type of ensuring the student. We tend to trust our student more, but we are hoping that student will not abuse it, abuse the trust, right? But there are some students still, especially my experience is in the main campus, there are more students, so there maybe probability wise, there will be some student that is, well, some students actually did plagiarize, especially during examination, okay? And they have to, when it's highlighted, they have to explain to the board of examination and to the faculty, defend themselves. Why? Okay, for example, when it's highlighted that, oh, why you answer something, right? And then they have to explain, right? So Plagiarism, please don't. Okay. Collusion means you copy from uh, your classmate, and the classmate allows you to copy. You're both of you colluding to fraud. I mean, this is fraud lah, right? Because you're saying that it's my work, but actually you copy from. So this, I'm just explaining what this term means of collusion. So you're trying to do fraud. You copy another person's work and present it as your own, but the other person also not innocent because they know you copy, but they allow you to copy. So you're both colluding to create fraud. But we don't call it fraud because there's no money involved, right? But very similar, right? So we call it plagiarism, right? Collusion means both parties in it together, right? Okay. So for academic, yeah, when you get information from not only from your friend but other places, articles or online, whatever, but you didn't acknowledge that is someone else's work or someone else, but you get it from somewhere else, you didn't acknowledge where you get it from. That mean that, and that means you're allowing people to think that that part actually you come up with it because you didn't uh, acknowledge someone's work that you are citing. Okay, again, not only in TAUC but also other institution, right? They look this very seriously. Okay, that's why everywhere you look, articles, books, whatever, there's always references at the back and there's always citation, right? Okay, so uh, on the internet there is plagiarism policy. Okay, so please refer to that if you want further details about, if you're worried, okay, is this considered plagiarism? Okay, there's a guide for you all. You can always ask me. Right. So I want to now to just go to the, okay, let's just look if you're late, as I said before, if you expect to be late and because there's a reason why, you have to let me know. Okay. So you don't have to come to this. But if, like I say, if you're late because last minute, you started like 2 days ago and then or something like that. This, if it's late already, fill it up, right? And fill up this assignment and then date it, okay? Right? You have to fill up this if it's late, okay? And then show you appendix, right? This is a part of the, inside. Let me just come back here. Here. Okay. Yeah. Part C here, declaration. Part C, declaration form for each team, right? Okay. So if solo, just fill up the single row, okay? And that part, you cross off appropriate lah, in this one as well. Okay, declaration, and then I think the last one is the appendix for rubrics also. Oh, here, rubrics, put after the declaration, put the assignment rubric. Say here, don't fill up this part, the score part, right? And the remark part, just include this in and fill up here this part only, up there. You fill up this part. The score part is the marker will place in the score, and then when they provide this as feedback again, then you can see here, and the marker might or might not put comments here, okay, right? Or maybe here remarks, most probably remarks, okay, right. Okay. So here you can see the rubrics. So each the rubrics here is actually group. If you are in a group, both members' rubrics will be filled up for each group member. Okay, and you can see here how do you get excellent? How do you get poor? Right? So you can see, only 2 subtype, 3 subtype here. All subtypes met, you get between 8 to 10. Right? Again, the same. Again, the same. So I guess you will expect, you will know what marks you get if you, because you know what kind of sub criteria you have met or not met. Yeah. Okay. But don't suffer in silence. If you're not sure, can consult me or consult your friend or consult internet or consult wherever, right? Okay. If you really stuck, for example, if you're doing even the practical, you're stuck somewhere, don't keep quiet. Okay. Let me know. And then here again, some more rubrics. Rubrics actually tell you, okay, what's the maximum marks, what the minimum marks, and then if the range of marks, how do you get that mark basically? Because the marker will use this to as a guide to mark your assignment, right? Okay. So I think that's all about assignment. Okay. Any question?
No.
No one. All right. So if no question about that, we'll go to our today's practical. Okay. So this is week 3. So practical, we have 2 packet tracer activity, right? Implementing basic connectivity, and second one, building a switch-based networking. Okay. Right. So there are 2. I'm just going to go straight something I already opened up. Okay, this one again. Yeah, this one first. Connect a wired and wireless LAN. So all the devices are here, including the end devices, intermediate devices, and something like the cloud. The cloud is basically going to represent your ISP, or basically the internet, right? Bring your ISP and other whatever inside the internet. The internet is very complex. Even the ISP configuration also very complex. So cloud is invented as a way to represent this complexity, simplified lah. So we don't really care what's inside, although we want the service. So we just draw a cloud and say that's the cloud. That's why when we talk about cloud, like the platform in the cloud, the service in the cloud, the web app in the cloud. What we mean by cloud means just the internet, right? It could be the internet, it could be the ISP network, it could be whatever, right? It's there, and you need the services, or you need the path through those internet work, but either you don't really care about the actual infrastructure there, or it's too complex for you to like draw as a diagram. So just draw a cloud. Okay. So when you see a cloud, that's what it represents. Could represent the internet. It could represent your ISP. It could represent something, whatever. Okay. But you know that I want to get to the internet. So how do I represent internet in my packet tracer? Of course, cannot, right? But the easiest way is, let's imagine the cloud I draw here is the internet, whatever. But if you go inside the cloud and you don't, how come so simple? Cannot be internet, right? Of course lah, right? We just represent it lah, pretend that it's the internet. For example, right? So here, what's missing? The missing here is the media. That's why this packet tracer is called connect or wired and wireless LAN. Because here you want to learn how to use this part. Okay, I'm highlighting it. You can see the circle there. Okay, connections. When you click on that, you can see so many cables. right? So many cable type. Okay, if you drag a wireless router inside, immediately you will see this kind of if you and then if you enable for each of the end devices the wireless NIC, then this thing, of course, you cannot set yourself. It's automatic lah already, yeah. So you cannot. There's no here. There is no we call wireless media for you to drag. Only the cables, right? That one will be drawn by packet tracer automatically for you. Yeah, right. So in this packet trace exercise, you have to decide, well, guided by the activity list, have to decide which cable to connect and how to connect. So let's have a look. Hopefully, is it this one? No, it's this one. Now connect a wired and wireless LAN. Right. So this one is not empty. It means they provide for you. So look at the device, find it on the packet tracer. Right, cloud is there, cable modem is there. So basically, when you connect media between one device and another device, is through the interface. Right. So which interface goes to which which device go to which interface which devices to look at here. What are the interfaces available on each of the devices, and the IP address for some of the interfaces already given. Okay, so the cloud interface Ethernet 6 connects to the fast Ethernet 00. On where? Then you have to look here. Okay, part 1 connect to the cloud, part 2 connect to router 0, part 3 connect to remaining devices. And then part 4, you will test how? Ping. And the B one is go to the family PC, find the family PC, open the web browser, type this address. If all the cabling correct, you should be able to see the front page, the index.html. And then performing verification means for connection means ping, right? Ping again from home PC, ping the switch IP address. How do I know what's the switch IP address? Then. So this IP address, because you know switch is layer 2. So what IP address is? We know I already mentioned about the the VLAN 1 administrative IP, so that you can connect to the switch remotely. Okay, so this is given already, so you ping that, right? At the bottom, I think you ping the switch. Where is this ping switch? There. And step 3, open router, open the terminal, configuration terminal, enter to view router 0 command prompt, show IP internet to view interface status. This one is just for you. I don't have to do here anything. You want to actually see that, right? That will tell you what is the IP, the IP address configured for each of the interfaces available on the router 0, right? And then part 5, examine physical topology. So examine physical topology means what? Once you're connected already, then that means from logical to physical topology. Showing you already how to do this. Go to click on the home city, and then whichever LAN you want to go to. Let's say home network. Go to home network. You can see the physical representation of all the devices in the home network. So go to logical and see home network here, right? Right. So go back here. So if you want to view others, just use that button up there, right? Can you see that? Yeah, highlight that. Click on that, you go one level up, then choose whichever. Right? To go back to logical, click on the logical topology tab, and you're back to logical. Right, so here you have to answer. So that means you create, if you have anything to answer from this activity file, open up your Word document and type the answer in, save it, save the file name with your name and the packet tracer so that you packet tracer file. So take this one. If it's a 4.6, use the same name. So it follows your packet tracer, so you know, okay, this Word document is for this packet tracer exercise, right? So what you do there, just examine and answer. So examine the cloud, click, how many wires connected to this? This is after, do this after you've connected all the devices with the correct media, or else when it says how many wires, there will be no wires because there is no media, isn't it? No media. So do the, of course, you do step by step, right? Do the part 5 after you did everything up there. Then, if you have connected correctly, you can see the wires in the physical topology. Then examine the primary network. Again, what is located on the table. Okay, you have to physically go there and check, right? Examine secondary network. Why are the 2 orange cables connected to each device? Well, not sure yet. You're not sure yet until before you connect all the medias, right? Okay, and do all the steps. By the time you do all the steps, ping everything, you probably will have an idea why are there 2 orange cables connected to each device in the secondary network. Then step 4, examine the home network. Click the home network icon. Why is there no rack to hold the equipment? Now, this one is logical, right? Imagine that home network is your home network. Why is there no rack? Think about your home. If you have a network at home, okay, do you buy a network rack? What is a network rack? Network rack basically is a standard size already depending on your equipment, where you can place your switch, your router, your server. Some servers actually looks flat and can be placed on a rack. It looks like a router. It's shaped like that, not like our PC, desktop, or laptop, where the shape is meant to be like placed on the table, placed on the table. This one is, some servers are shaped in such a way, designed in such a way that fit on the rack, just like a switch, like a router. Okay, think about the physical layer. Remember the body that in charge of the organization that's in charge of all the standards. So the rack, okay, also follows the standard. If not, then when you try to fit your switch, your size into the rack, okay, cannot fit. Too small or too big. But there's different types of sizes of rack. Then for this, you have to see the standards. Usually, the network or IT provider, service provider from companies that sell these kind of things, they will have catalogs. And they can tell you, okay, this one fits what kind of model of what you have, right? And how much does it cost? Some racks are open racks. Some racks, it's actually enclosed like a closet and you can open, but the door has like a glass, you can peek inside lah, right? You can open and close, right? Okay, some racks, if it's like a closet, you can open and close, will have power and ventilation. And last time when we bought, before the MCO, we brought our students to one of the company, I think it's Sabah Credit in Dongwon. They have this IBM Blade server, right? So good. Our students actually allowed to go inside the server room, very cold. They maintain the temperature. And what's interesting is that the rack is like a closet type that you can open, but it also have this kind of ventilation and what do you call that? It's like a freezer, right? They want to maintain the temperature. So inside the room is already very cold. Inside because to cool down the server and whatever, because heat is the enemy of all electronics devices. So inside, we can see the temperature. It's like a fridge. Then you can open, close, but then inside the temperature is even more colder, right? So sorry, I did too much, but then you ask yourself, why is there no rack to hold the equipment? Only you can answer that. What do you think? There are people online. You just Google like home network whatever, because they have their own data, and then data needs and computing needs are at home. Some of them actually do have racks. Okay. And when you look at it, well, they purchased from eBay some of the previous servers, and people, company, upgrade, right? Because they scale up, they feel that the current equipment, okay, not suitable anymore, they auction off on eBay or they sell, okay? So they buy new ones. So if you can go and buy a rack and then buy a switch, a proper switch, for your home router, server, to keep all your media, your cloud, all this. You create your own cloud. There are software like Open Cloud that you can install inside your server at home, and it acts as instead of using people cloud like OneDrive or Google Storage or whatever, you can use your own cloud. Okay, some people do this lah. Right? But why is there no rack to hold equipment? I think you can answer all this equipment. Okay, very expensive. Right, very expensive actually, even on eBay. Right? And some people they actually follow what the enterprise do. They have a backup of their setting, and then also they have offsite backup. There was this guy, and he was asked, okay, where do you put your backup stuff? Oh, in my parents' house. He actually have a closet in the parents' house, and backup equipment there, backup storage there at the parents' house as the offsite backup for his computing needs at his own house. Yeah, I found that kind of funny there. But yeah, there are some. These are hobbies, but they actually, you will be surprised. They buy terabytes of hard disks, and then to store their, basically act as a store their own personal cloud, right? All right, so please do this. I think this is just a reflection of what we studied this week in the chapter on physical layer. We talk about media, right? We talk about copper cable, talk about fiber optic. I don't think here we need to install fiber optics, depending on, yeah. You can see here, for example, connect the cloud to router 0. At the bottom left, click the orange lightning, which is that basically. And then open available connection, choose the correct cable to connect from router interface that to cloud. Okay, so cloud is a type of switch, so use copper straight through. So which one is copper straight through? So this is copper straight through. So which interface on the router? Pass Ethernet 00 and the cloud Ethernet 6. So okay, we take that. What we're gonna do is on router 0, pass Ethernet 00 to Ethernet 6, right? Yeah, Ethernet 6. So I just did one here. It says if you attach the correct cable, the link lights on the cable turn green. So yes, it did turn green, so I know it's successful. So next, go to connect the cloud to cable modem. So now cloud cable modem. Just follow step by step, making sure you see the interface. For this one, it's router 0 serial 000 to router 1 000. Follow the interface when you select which interface to connect the cable to. So use one of the available serial cables. So serial cables, either this or this. Choose one. If it's not green, remove it. Choose another one. Right? How to remove? Well, here's the delete. Okay, you click that, become X, right? Then select on what you want to delete. Right? And still X, huh? Be careful. So after you delete, escape. So then you use another cable, right? If it doesn't turn green, means you use the wrong cable. So that allows you to delete, okay? And then choose another cable and connect. Okay? And simply connect all the medias until you reach part 4 where you want to do the ping. And the web browser check that. How to get to the web browser? So basically on the family PC, go family PC, go to desktop, and then find the web browser there. That's the web browser. You open it, right? Type the URL here, given already, yeah, in there. Right, and then if you can access it, that means okay, this part is successful. Then follow through lah. Huh? Right, any question on that one? Straightforward?
So far no.
I think that one is straightforward, then. Just select the correct cable, link, follow the steps, and then do the testing, and then go to the physical topology and observe what you see, and then write your answer. Right. So
we only use the black wire. The copper.
Depending the black. Okay, now of course you're not used to the term. The black cable you mean is copper straight through, right?
Mm-hmm.
Yeah, copper straight through. No, if that one is for that. Then okay, so here choose the correct cable to connect cable modem port 1 to wireless router internet port. Okay, correct cable. That means you have to think about what is the correct cable to connect that.
Is it possible to have different kind of correct cables, or is only one kind of cable can work?
I think only one kind. I think this activity has been designed to have one kind, right? And how do you diagnose? Again, once you connect it, if it's correct cable, it's green. Okay, this is to test your understanding about what kind of media is used to connect this and that, right? So the one I shown you, right, here up here, right? So the router connects to the switch. Usually we use copper straight through, right? So here, cloud to modem port. Since that is a coax port, right? So what cable do you think? Coaxial, right? So highlight, find coaxial, fiber phone coaxial, right? So this involves a bit of detective work for you, right? And understanding about the media, the different types of media. So this is the practical part of our lecture. Okay. In lecture we talk about all the different types of. So now you have selection here, right? So here you can try and narrow, but of course just don't simply try everyone want to do an educated guess. I think, oh, this one should be this. If wrong, don't worry. It's a part of learning process. Delete the cable, then go to your second choice, right? Okay. Any other questions?
No.
No.
Okay, if not, then let's look at the second. I think it's this one, second packet tracer exercise. Right, this one, right? Implement basic connectivity. So, in the previous packet tracer, when we do the initial configuration, right? We did all the configuration except learn how to attach or to configure IP address on interface. Okay. And also we know that switch will have administrative VLAN 1, the interface that we can set the IP address because we want to connect to the switch via network in order to access the SSH terminal so that we can configure the switch remotely without using console cable, console port. That means remotely via network. Okay, we know we can do that, but we haven't done, right? So in this packet trace exercise, we will do that. If you can see here, open up the packet trace activity. I think this one, yeah. Oh no, not this one. Let me just check which one is it. This one is this now. This one, yeah, this one. Implement basic connectivity on this, right? So let's have a look. So here, addressing table is given. Usually, if they give you this, that means you need to refer to that. So here, give you the device, the interface, and the IP address with the subnet mask. Now, when you are assigning IP address to an interface, usually on the switch or on the router, and on the computer, but on the computer, usually it's if you type it in the config IP, subnet mask, if you tap to the subnet mask field, it will automatically give you. Okay, but in the switch and router, you have to type at the back. After you type the IP address, space, and then you have to type subnet mask. You can see, I think it's in here, something like this one, the command to, yeah. So you type IP address. This is IP will be for IP version 4. Later, once we learn about IP version 6, we need to do the same one, but instead of IP, we'll type IPv6 actually. Okay, but don't worry about IPv6. That one's for later. So you go to config terminal, and this is a switch, right? And then when you insert config, you type interface and what interface you want to. So if you want to do the management interface, so we type VLAN 1. Once inside, you can see the config interface there. Then you type IP address, and what is the address? Then you see here, VLAN 1 for S1 is this IP address and this subnet mask. Right, so when you come in here, you type that IP address first, and then space, and then subnet mask, press enter. Right? And it's not complete yet because you have placed the IP address for that interface, but don't forget, every time on the switch or on the router, whenever you configure or reconfigure the IP address, don't forget to type no shutdown. Okay? Just to be safe, never fail to type no shutdown. What is no shutdown? Means the opposite of shutdown. By default, most interfaces on switches and routers is deactivated. Okay, it's in even though it's powered, okay, but the interface is closed. It's shut down. The interface. So if you forget no shutdown, even you type the IP address here and the subnet address, the interface will still not work because it's in a shutdown mode. It's administrative down. Okay, why this kind of configuration is available on switch and routers? Because later on, it's not in this course. Okay, I'm just going to mention it so at least you don't wonder. For security reason, it's always a good idea for those ports or interface that is not used, you actually shut it down. Why? If someone have access physically to your switch, even though you protect all the other ports or interface, maybe for that port which is empty, maybe something plugged in, maybe you didn't configure because you think it's empty, no need to configure that one because there's no cable. But if someone managed to access physically your switch, they can just plug in. And if there's no security there and it's not shut down, they plug in straight away, they can have access to your switch. So for security reasons, usually by default, all the ports or interfaces are in shutdown mode. Right? So if you configure and you don't type no shutdown, means the opposite of shutdown, means bring it up. Then you might be pinging, how come doesn't work? I already set the IP, but actually the port is interface is down. So after every time you configure the IP address, whether for the switch or the router interface, type no shutdown. Okay, this one have to get used to it, right? Okay. So basically, in this exercise, you are going to set the IP address for switch, the VLAN one, also the PC. So for PC, I'll just click on the PC, go to the IP configuration. This is already manual, static. Type in the address, subnet mask. Don't worry about the default gateway and DNS server because single LAN and it's offline to other network. Okay. Right. So, but of course here you do this, which is what we did last week. Okay. Just follow this. I think this one you already did earlier on, like this one. Banner text is MOTB, right? Like this one. But after step 4, you save configuration, you save running config, a copy running config, setup config, right? And then part 2, configure PC. Okay, so what I showed you earlier. Okay, go to this one. They show you exactly the step what I show you. Put in the addressing for PC. Okay, for both PC. Refer to what address to put from this addressing table, right? And then test connectivity to switch. Successful or not? Explain it. Okay. Well, you haven't configured the switch, right? So I think that has something to do with it, right? So go to part 3, configure the switch management. I shown you earlier this one, and then do the same for switch 2, and then to verify. Okay. So inside actually go to privilege mode in both switch 1 and switch 2. Switch 1 first. Type this command, show IP interface brief. It will actually shows you, for example, I will go to switch 1. Okay, and here, okay, enable, and then I'm here, show, the command is here, show IP interface brief. Brief means don't show me too much, show me the brief information. This is this command is actually good for troubleshooting. Show IP interface brief will show you all the interface available on the switch and its IP address. Okay, let me just make it bigger, so like that. Right? Okay, and you can see there, fast internet 1 and 2 is already up. The rest are down. That is the part where no shutdown. Okay, if down, typing no shutdown for that interface will bring it up. All right. Okay, so IP address all unassigned. Right, but later on when you assign, it will actually show you the IP address. So using this command, you can straight away see for all the relevant interface whether the IP address configured for that interface is correct or not. So this is a good command to do troubleshooting, like this one. Oh, did I do a typo? Did I type in the correct password? How do you know? Type this and you can see. All right. Example, then after you finish, okay, save configuration, right? Save configuration, and then answer that command in separate file. Then do something to verify. Means using ping, right? If you can ping successfully all, means what you have configured all correct. So this exercise, in summary, teach you how to configure IP address for PC and the administrative interface for switches. The previous one tests you or teach you which media is correct for which for which devices, and how to use the media to connect the two devices. All right. Okay. Any question? Any question on this part? Implement basic connectivity?
No, for me.
Okay, Farrell, okay.
Yeah.
Right. So typically, you're right just to follow step by step. All right. So previous exercises, market activity. I'm hoping that you guys at home will try to complete it. Okay. And if you have any question or difficulties with the previous ones, also can raise up. All right. What about the rest, Noel and Kelvin? Any questions for
No.
this activity? No.
No.
Right. If not, then I'll leave you to do it. We have about half an hour left. While you're doing, I'm going to monitor. Okay. If any question, please let me know. Okay. If you cannot finish by end of this session, please do it as homework. Okay. So and these two, I don't have to say that it's important because these two exercise teach you different skills with a packet tracer, right? So need to know how to do both of this moving forwards, because later when we go to the next exercise, other things will come in. So when you learn about other things, this previous exercise will be assumed you know how to do already, right? For example, you can see here, no more steps given to you. They assume from last week you already know how to do MOTD. Okay, so now they just tell you, okay, show this banner. Means what? That means use the technique last week, how to configure the MOTD to show this banner. If, like this also, console password. They assume you already know the commands to set the console password. They say use Cisco. Right? So I will tell you that the SBA much later at the end, towards the end of the semester, will be like this, right? They will give you the what you need to configure, but how to configure it, they assume you know already because you've done the exercises. Okay, that's very important that you complete each exercise for the practical because it builds up your knowledge how to use packet tracer, how to configure things, all this. So by the time we reach the subnetting and the DSM, means you, for all the configuration needs, you already know how to troubleshoot, how to test your network, how to configure switch, all this, right? You already know. So now we are looking at the higher level network whereby, okay, so now I'm thinking about how to design the addressing scheme. Okay, that becomes the most important part later. Then after that, oh, okay, so from the addressing scheme I design, which address should I assign to which device? Once you decide that, then you just go to the device and configure. Okay, so for example, here we learned how to configure IP address for the VLAN 1 switch and also the PC. Okay, that's a step that say you decide all the address to configure for the device. Then when you actually do the configuration, then after that, the next step will be to test, right? To verify. Then you need to do the ping. Okay, ping from this PC to you want to know whether all your IP addressing configured correctly, all your other configuration also correct. Then you have to test the network looking. All right. Okay, so I leave you guys to do the exercise. Yeah. Anything, just raise up.
Okay, sir.
Okay.
So does the must there be a green arrow for the to show the cable are correct?
Hello, sorry, can you repeat your question?
Yeah, I tried to connect the
Which one?
I tried to connect the console to RS232 with using the copper straight wire. Oh, but I don't see a green arrow when I finish connecting
Oh, okay. Which one? Okay, let me see.
the console
You're
to
still on the connect wired wireless LAN.
yeah
Part what?
yeah I'm still at part one. I'm still connecting.
Which one? Part two? Part three?
Oh, I didn't follow the part. I'm just following the table connecting right now. Only. Or do I have to follow the
Yeah,
step
follow
one by
this. Yeah, follow the steps
one? One by
because the table might not show you in sequence.
oh
So yeah, you should follow the part one, step two, part two, step one. You follow the instructions.
okay.
Yeah, but let me see. Connecting console router connects to RS232 router 0. Uh,
Is it is it the copper? Is it using copper?
no, console cable.
Using console cable? Will the
Yes.
console cable have arrow if I connect properly, or will there be no arrow? Will there be a
Uh,
green?
should be no error. No error. So that means router 0 console to configuration terminal should be, yeah. So configuration terminal to router 0. On the configuration terminal should be RS232 using console cable, okay, to router 0 console port,
Okay.
okay?
So before
Yes.
I use the copper crossover for the
Sorry,
for that
which one?
one, the configuration and terminal into
Yeah,
router 0. I use the copper crossover.
copper crossover? No, for configuration terminal, using console port and RS232, you have to use console cable.
Oh,
Okay, so to test that, you can actually go to the configuration terminal after you connect the cable, and let me just show you. Yeah, right. So once you have a cable to test whether you can connect. Actually, go to desktop, click terminal, click OK. Right. See, of course, there's no cable. Then this one is not showing me anything. Right. So if I use console cable, it's always console cable for console port. So RS232 router 0 console port. Then when you go to configure terminal, go to terminal, click OK, accept that. You can straight away see it's different, right? This shows this one, line protocol on interface change state to, oh, this one, sorry. No, the thing is, it's actually straight away connected, and what you're seeing is what you should be seeing on the router 0 itself. Okay, so now to show that it's successful, you can actually see the router 0 prompt. Okay, if you use a blue cable, it probably won't show this. It will show you blank screen like what I what in the beginning. Okay,
Okay.
right? So if you did this correctly, that means you use console cable 62 on the computer cable and the console port on the router 0. Then this will appear. That means when you see this prompt, that means you are connected to router 0. That means you can now use the command interface. Okay, so understand that when you do this physically, that means you have to be physically close to router 0, because this console cable does not transport any network data. Okay, console cable is not a network cable. Thereby, it's actually a communication cable, RS-232 standard. Okay. Okay, the RS-232, if you want to see behind your computer, it actually looks like COM1, right? COM1. It's the label will be COM1 or COM2. Okay, but we call that RS-232 because RS-232 is the standard for communication port, COM port, right? Okay, I'm not sure I can see the back. Here, yeah. So it's USB. Let me just zoom in. Let me just see whether they actually show here. They actually use a different connector. So let me just show you in the real life what it looks like. Yeah, look like that, 0 port. Look like this, COM1 port look like that. This is a standard COM port at the back of your PC. It's called 0 port.
Do we
right?
still use this nowadays?
Yeah, it's still there. It used to connect, if you recall the very old modem, the one that has that weird sound at the beginning when it's connecting, maximum speed 56 kbps. You know, that kind of modem last time, not now, is obsolete already. Last time was provided by Jaring. The Jaring company also now, I think, is no longer in service, right? So yes, this used to connect to that. Okay. The other type of COM port is slightly larger, but this is the typical one we use. Okay, 0 port is a serial communication based on RS-232 standard. Okay, and that is what the console cable actually is following, is that kind of standard. But on the backplate of the switch or router for Cisco, they don't use this port. They use a modified version of it looks like if you roughly look at it, it looks as if it's like a RJ45 connector. So that's what the confusions are usually. But it's actually, they use the connector, but they follow the wires standard for RS-232. See here, and this Cisco console port. How does it look like? Okay, show. Yeah. So you can see compare that and that. It's different. Okay. On the back of the PC, still follow the international standard where the RS-232 COM port is actually like this. It has all these pins. I think it's about 5, 6, 7, 8, 9 pins right here. Okay. So that means what the connector that you plug into this will be like this. Okay. the male on the backplate of your PC and the female look like that. So you plug in. But on the other end, okay, it looks very similar to the Ethernet RJ45 port. Now that's the problem. But well, I think Cisco just prefer to use their own port. They call it a console port. Okay, so it's proprietary to Cisco, this connector. Okay,
Okay.
right? So in real life, it looks like this, the rollover console port. So this part, you connect to the back of your PC. Right? When you're doing the other course, the more advanced course for networking, the CM, computer networks course, the next course after this course, when you actually will have access to the hardware, then you will be using this as a console port. Sorry, console cable. So this is actually the console cable that we here. Okay, this console cable is this, because at the back of the PC, let me just go back to the previous one, is this COM port. So you plug this into that. But for Cisco, their console port looks like a RJ45 port. So at the Cisco part, this connector plugs into. Okay, but this cable is RS232 communication cable, right? You get what I mean, huh? Just that Cisco did not follow this standard for connector. They come up with their own connector at their backplate of their switch and routers. And of course, this cable, because it's not a network cable, it's not an Ethernet cable, it's a communication cable, a serial communication cable. So network data will not flow through this cable, not compatible. Okay, so the only communication that supports this kind of cable is a direct point-to-point communication, which is the terminal communication. So what you're doing is when you connect this at your PC and this at the switch or routers, whereby in this kind of configuration, so on your PC, you will have to run a terminal program. So in real life, there are many. You might use something, a software called PuTTY. PuTTY is just one of the software available, okay, as a terminal client. You can download, you can use for free. Okay, but there are many. PuTTY is just one of the standard being used for ages already. People like it, right? So in fact, we'll probably be using PuTTY when we are using the real hardware. Okay. So configuration, we can see the configuration like that. We can do a lot of configuration. But what it actually does is it will open up something like this, the terminal. So here we are connecting to a Linux terminal, but it also can connect to the router or switch terminal. As long as the terminal server, okay, that means the client is from the desktop part. The terminal server should be at the switch and router. Follow the terminal standard, the terminal communication standard via serial port, serial cable. Okay, is that okay?
Sir, can I
Yes.
present?
Yeah, sure. Hang on. Go ahead and take over.
So my one like this.
Oh, green, huh? So
Yeah.
now you have to verify. So I think all green to be okay already
So
in terms of configuration. Now you have to do
next one.
this part. After you connect everything, you do this part. Verify
Okay.
connection. Yeah. After verify connection, you switch your view to physical topology, which is that part. Yeah, that part. So then click home city, go and then choose which LAN you want. Basically, here it shows here. First, click cloud, and then when you click cloud, you can drag the pen through the view lah, right? To see what's inside there. Then just basically these are just questions I ask you to think about it lah. So how many wires do you see connected to the switch, for example, in the blue rack? So yeah, how many wires you see?
2.
Two, right? Then you answer two. So then do the next one. Go to step 2. Examine primary network. But before you do, this is the last part already. Okay. Before do that, do part 4 first. You go to the family PC. Go to the command prompt. Okay, desktop. Desktop can be command prompt can be found in the desktop of the family PC. Then you type this command, ping that. If it's successful, okay, you can go to what for? Go to click on primary PC, go to command prompt. Okay, then you type ping netacad.pka. Press enter, and then you'll see whether what is the result. If you find that it takes some time, you can go because this is like a simulation of real network. Sometimes the configuration need time to propagate. Then you can go down on the blue line at the bottom. There's something like a fast forward. Yeah, you can see successful, right?
No,
Okay, successful. That is successful. Yeah, that means there's a reply. That means it's successful.
No.
So the delay is usually because they want to simulate the real network, so they also simulate the latency. Okay, they simulate the latency. In fact, if they do simulation without the latency being simulated, everything is just very fast. Everything like fast, which is unrealistic, right? But in the real network, as I was talking about the latency earlier on in the lecture, there will be slight delay. So that means it's all successful. There was all reply. So all successful means you pass that test. Then you go to the next test, which is step 1B on part 4. You open the web browser. So back to desktop. That means close. Click the X. Click that. Not that one. Go back to family. Yeah. Go back to family PC. Go to desktop and scroll to the right, and then web browser. And then type the URL http / netacad.pka. Okay, then go. Yeah, so successful again. So that means you are looking at the index.html, that means the front page. So that's successful. So both successful for step 1. Then go to step 2. Now open home PC and try to ping the switch IP address. That means your own IP address. So your home PC is connected to, let me just check my, Yeah, your wireless router is typically is your switch as well. So let's just see like this here in your oh, maybe it's the switch, the actual switch, yeah? Device switch IP address is 172.16.02. Try to ping that. Okay, for the switch, the IP address is 172 dot something, right? So at the home PC command prompt, you ping that IP address. You can copy and paste. Press enter and see whether success. Again, there will be latency. If it's timing out, yeah, if it's timing out, you just wait. Do it again. That's because it in like a real network, everything have to propagate. Can you just arrow up one time and press enter again? It means you redo the command.
Arrow up.
Yeah, press enter again. This time all four should be passed. Yeah. So again, it's a success. Okay, so step 2, successful. Okay, yeah. Now you do the step 3, which is the final verification. So that means you go to the config terminal, configuration terminal connected to your router. Okay, click the configuration PCS, go to terminal. Okay, click OK. That means you're in, right? Press enter. Enable to go to privilege mode. Now in privilege mode, you want to type show IP interface brief. The fact that you can connect to router 0 means you use the right cable. Okay, then the fact that you can successfully type show IP interface brief means you can now see that means this is a success lah, right? Means you're able to do this. That means your cable from your configuration terminal to router 0 is correct. You're using console cable. Okay, so you successfully complete part 4, verify connections. Yeah. Okay, so the rest also I've been watching. So the rest also, when you're doing part 4, do exactly the same. If you encounter a delay, the ping, just wait for it. Okay, wait for it because this simulator try to emulate the real live network with the latency, so there will be delay. Okay, so just wait. If you after you waiting you still fail, that means some of the cable not correct cable, right? Or not only the wrong cable. You need to know whether you use you connect to the correct port. But if you have been following the instructions closely, you would have chosen the correct port already or interface, because it's given as part of the steps above. So after you finish 4, you go to part 5. That's part 5 basically just observation and knowing how to go to the physical tab to look at the physical topology diagram, how to navigate there. If you just entered, the first thing is to click on the home city. After you click home city, you can then see different LANs. Okay, step 1 asks you to examine the cloud. Step 2 asks you to examine the primary network. Step 3, secondary network. Step 4, home network. So basically you go in and observe, explore there, observe what you see, okay, and then try to answer the question. Okay, the question here is just based on observation. For example, step 2, examine primary network. It says, once you can see, it asks you, what is located on the table to the right of the blue rack? So basically, just observe what is there and then answer. All right.
Sir, this one is the power switch. Is it counted as a wire?
The power switch.
Oh yeah.
No, they ask you the wire, okay? How many wires?
Oh yeah. So is it included?
Oh, how many wires are connected to the switch in the blue rack? So power, no. I don't think it's asking about the power cable.
Oh, okay.
Okay. How about the rest, Noel and Farah? Any questions so far?
Still doing.
Yeah, still doing.
Okay. It's already 11:15. Not sure whether you have another class later. Okay, I don't want to take your time. Just in case. You guys got another class later?
This is the last class.
Okay, so it's already 11:50. We've gone beyond our time. Okay, so
Okay.
all right. So thank you for today. Any questions? Of course, you can ask me. Now, usually, we'll create a WhatsApp group, right, for all my classes. So I noticed that we don't have a WhatsApp group for this, right? We usually use the WhatsApp group for urgent matters lah, any announcement or any urgent questions or things like that. All right. So here is my number.
Sir, we already have the,
Yeah, everybody.
Already gone? Already, but
yeah.
it's because it's silent, that silent group. So that's why I'm not. I forgot about it. Okay. All right.
Okay, sir.
No worries then. All right. Thank you very much, everyone.
okay. Thank you, sir.
Okay, sir. Thank you, sir.